Welcome to CIVIL-MECH-MATHS Concepts by IITIan. In this lecture, as a part of the Quantitative Aptitude QA for CAT, GRE and GMAT, I will be discussing an exponential equation, behavior of the exponential equation, and to find the roots of this equation. This equation is not an ordinary equation. The power of the equation is in the terms of the variable. X is a variable. It's not like ax square plus bx plus c is equal to 0, or it's not a polynomial where a into x to the power of n, b into x to the power of n minus 1, it's not a polynomial also. The power itself is a variable. It's an exponential equation. It's a typical equation. We have to find out the behavior and we have to solve for the roots. When you know the behavior of the equation, it will be easy for us to solve for the roots. And the behavior of the equation can be found out by assuming graphically how it looks. By drawing it graphically, we can understand the behavior of the equation, behavior of the curve, and then we can understand the roots of the equation and behavior of the curve by drawing it. Let us try to solve this question by using a logical approach for drawing this particular curve and also logically arriving at the solution. Because this question or this problem doesn't involve a straightforward equation. It has an exponential, the variable x. Let us try to solve it. What is the question given? We have to solve and we will solve it. We will draw the graph. We will plot it so that you will understand the concepts. How these exponential equations will behave. Then in the examination, whatever type of questions being asked to you, you will be answer them without any difficulty, with confidence. Let us try to understand the concept behind it. The thrust of this lecture will be to clear the concepts and to make understand the behavior of the different mathematical questions, algebraical questions and equations, so that you can apply these concepts in the actual examination in a better manner. Let us try to understand the concept behind it. The question is 3 to the power of x minus 2x minus 1 is equal to 0 is the given equation. We have to solve it. Here we are not only solving for x, we are plotting it, because I am expanding the scope of this question, plotting it and understanding the behavior of this curve. It's an exponential curve. Once you have all these three things together understood by you, any question being asked in the examination, you will be able to solve it in the exponential questions of this type. Let's dwell into the answer. Solution. The given equation is 3 to the power of x minus 2x minus 1 is equal to 0. When a particular equation of any sort will have a solution for a particular value of x or any variable if the equation changes its sign from positive to negative or negative to positive. Now, let us try to understand the behavior. If by trial and error method x is equal to 0, what happens? Function x is equal to 3 to the power of x. The given equation is function x. It is a function of the x in terms of x. 3 to the power of x minus 2x minus 1 is equal to 3 to the power of 0 minus 2 into 0 minus 1, that is equal to 1 minus 0 minus 1, that is equal to 0. That means function x is equal to 0 when x is equal to 0. Implies function x is equal to 0 if x is equal to 0. That implies that satisfies the given equation. Hence, x is equal to 0 is a root of this given function. This function is an exponential curve. Second, if x is equal to 1, let us say, what happens? Function x is equal to 3 to the power of 1 minus 2 into 1 minus 1 is equal to 3 minus 2 minus 1 is equal to 0. That means this value also satisfies the given equation. That means if x is equal to 1, function x is equal to 0, that implies x is equal to 1 is a root. Now, if x is equal to 2, function x is equal to 3 square minus 2 into 2 minus 1, that is equal to 9 minus 4 minus 1 is equal to plus 4. That means it is increasing. Because it is an exponential equation, it increases. The value of 3 to the power of x increases when compared with 2x. Because this can be written as 3 to the power of x minus 2x plus 1. Can we write like this? Yes, we can very well write like this. This increases fast than this one, 2x plus 1. 2x plus 1 is a linear equation. 3 to the power of x is a exponential. 2x plus 1 is linear. Always exponential term increases faster than the linear term between certain interval. Hence, function x can never be 0 beyond x is equal to 1. For example, x is equal to minus 1. Function x is equal to 3 to the power of minus 1 minus 2 into minus 1 minus 1. We have just substituted the value of x as minus 1. That is 1 by 3 minus into minus is plus 2 minus 1. That means 1 plus 1 by 3. X is equal to minus 2. Function minus 2 is equal to 3 to the power of minus 2 minus 2 into minus 2 minus 1. That is 1 by 9 plus 4 minus 1. That is equal to 4 plus 1 by 9. 3 plus 1 by 9, sorry. 4 minus 1 is 3. 3 plus 1 by 9. Here, 3 to the power of negative values will be changing at a lesser rate than the linear. Linear moves faster than the exponential when power is negative. Hence, for any value less than 0, this particular function attains a positive value. That means the behavior will be like this. Please try to understand me. This is x-axis. This is function x or y-axis. When x is equal to 0, function x is 0. This is one point. When x is equal to 1, function x is equal to 0. This is another point. 1, 0. This is 0, 0. But beyond 1, it is always positive. Beyond 0, it is always positive. That means there are no points between 0 and 1 where the function will be 0. Then we approximate this function to be like this, the curve to be. It is an approximation, blue line. We will finalize after few minutes. This is actual behavior. This is actual behavior because beyond x is equal to 1, the function is becoming positive, positive, positive only. It doesn't come back to negative. Hence, it will not have a root. Lesser than 0 also it is becoming positive, positive only, and it cannot have a root. Lesser than 0 and beyond 1. For x is equal to 1, beyond 1 also there is no root. For x less than 0 also there is no root. Now, is there any root between 0 and 1? That is our intention to find out. Is there any root? This is only approximation we have done. Let us say x is equal to half. Then what happens? 3 to the power of 1 minute. We will write like this. Function half is equal to 3 to the power of half minus 2 into half minus 1. What is the square root of 3? 1.732. I have told in the previous classes, you find out root 3, root 2, root 4, root 5. Please keep those values ready with you. Minus 1, minus 1. That means for x is equal to half, this gains a negative value. Minus 2 plus 1.732, it will be minus 0.268. That means there is some value at half, it attains a value of minus 0.268. That means the curve goes below the x-axis. Between 0 and half, beyond the value of 0 for x and half for x value as half, there is a, from positive to negative, there is a sign change. Hence the root is here. We concluded. When x is equal to 1, what is the value? Value is 0. That means between 0 and x is equal to 1, x is equal to 2, it is almost plus 4. X is equal to 2, it is almost plus 4. 2, 4. That means between x is equal to 2 and x is equal to half, there is a positive to negative value. There is a transition. This transition point is called as root. You are able to understand, I feel. That means the curve is a convex curve having roots at x is equal to 0 and x is equal to 1. It's a convex curve having roots at x is equal to 0 and x is equal to 1. And we can say that safely. Can we find out any positive value between half and 1? Is it possible? At half it is minus. Can we find any other value? X is equal to 3 by 4, let us take. Function 3 by 4 is, this is how we have to find out the behavior. 3 to the power of 3 by 4 minus 2 into 3 by 4 minus 1. 3 to the power of 3 by 4 is 3 cube 4th root. Find out the value. 3 to the power of 3 by 4. Just have some idea. Rough idea. If you are not provided any calculator, please let's have a rough idea. Three to the power of 2 is 1 is 3. 3 to the power of half is 1.732. It is between 1.732 and 3. That means it is approximately, we can take it as 2.28 minus 2 into 3 by 4 is 0.75 into 2. 0.75 into 2 is 1.5 minus 1. That means 2.28 minus 2.5, that is minus 0.22. It is still negative. X is equal to 3.4, also still negative. X is equal to 1, it is function 1 is equal to 0. That means it is increasing. This function value is increasing as x tends to 0 from minus half. And towards this side, towards the other side, x is equal to 1 by 4, let us say. Function 1 by 4 is equal to 3 to the power of 1 by 4 minus 2 into 1 by 4 minus 1. What is 3 to the power of 1 by 4? Please, 3 to the power of half is 1.732. 3 to the power of 0 is 1. It is in between 1.1 and 1.732 approximately. It is approximately 1.32 minus 0.5 minus 1, that is equal to 1.32 minus 1.55, that is equal to minus 0.23. Sorry, it is not 1.50, it is not 1.55, 1.50 minus 0.18. That means the value of function x is increasing from minus 0.268 to minus 0.018. Here also it is increasing. So that in this portion, between x is equal to 0 to x is equal to 1, 1 0 0 0, at half it is 0.268 minus, it is 0.18 minus, it is 0.22 minus, so that it is increasing. There is nowhere it is becoming negative. It is changing the sign from negative to positive. That means we have almost negated the shape. The shape is like this. This shape is negated. Hence, the possible solutions, the roots of the equation are 0 and 1. X is equal to 0 and x is equal to 1. If you have knowledge in calculus and some amount of working knowledge in calculus, it can be found out that we can easily find out from calculus what will be the shape of this curve by calculating the second derivative, that is the second method. That also you will appreciate, because this type of problems, they can be done using calculus also. Sometimes you better use calculus. Using calculus, if calculus you are not familiar, please use the previous method. If you are familiar with the calculus, please use calculus method. When you use the calculus method, function double dash x is equal to, what is function x given? 3 to the power of x minus 2x minus 1. Second derivative of function is equal to 3 to the power of x into ln 3 whole square. This you do it as a homework. Because for any value of x, x may be negative or positive. This value, this particular value, is always greater than 0. If x is equal to 3, x is equal to 0, function double dash x is ln 3 whole square, that is positive. If x is equal to negative also, that is positive. If x is equal to positive also, it is positive. When from calculus function double dash x is greater than 0, that implies it is convex. Between the roots it is convex. That means it will be like this. This is one root, this is. That means in between these two roots 0 and 1, we can definitely say that there is no other root because it is convex. Hence, we can say that it has two roots as x is equal to 0 and x is equal to 1. Two roots for this equation. Roots we have found. Then graphically we have seen how to solve this problem. Understood? And at the same time we understood using the second derivative. Now in this question we have used the concepts. One is exponential equation with variable as exponent. Then graphically could assess the behavior of curve, exponential curve, and with calculus we could say the behavior of curve as convex, between the given two observed two roots, not given, they are observed two roots. With this I want to conclude the lecture, and if there is a value addition to your knowledge because of this lecture, please kindly share and subscribe to my channel CIVIL-MECH-MATHS concepts. My lectures will be mainly focusing on the concept so that any type of question being given in the examination can be answered with confidence by you. That is the aim of this lecture series. CIVIL-MECH-MATHS concepts. Kindly share and subscribe.